In this module, we will talk about the anatomy of a package in part 1. So in this first part, we'll talk about the key components of a package and the types of packages. So all packages have these basic features. Of course, you'll have the integrated circuit die. Then you have the FLI, first level interconnect. This is what makes the connection between the IC die and the package substrate. Typically for a flip chip, uses a solder plus copper connection, solder connected to a copper pad or pillar. C4 is a very typical way of doing this. C4 stands for controlled collapse chip connection. And typically, these first level interconnect joints are spaced anywhere from 100 to 200 microns apart. Then you have the package substrate. Now, this is what does the transformation from micron-sized features on the IC chip to millimeter-sized features at the system. It is a multi-layer stack of alternating layers of copper and dielectric, anywhere from 6 to 24 layers in the stack, and anywhere from hundreds of microns in thickness to 2 to 3 millimeters in thickness. And then finally, you have the SLI, the second level interconnect. And this is what connects the package substrate to the system. Typically, this is a ball grid array, which uses solder bumps to surface mount to a motherboard, or LGA, land grid array, which connects to a socket. So rather than surface mount to a motherboard, it gets connected to a socket which is attached to the motherboard. Typically, SLI joints are spaced anywhere from 400 microns apart to a millimeter apart. Let's expand on what is in a package and talk a little bit more about some of the other components. So in the picture, you can see the FLI, the SLI, the IC chip or the silicon die, and the package substrate that we talked about previously. Also in this picture, now you can see the transistors, which sit at one side of the die. In this case, for a flip chip die, sit very close to the substrate surface. And I've also included an underfill. An underfill is a polymer that is used to protect the FLI and dispensed underneath between the die and the substrate. Package can also have passive devices like capacitors and resistors. These are to help manage power delivery and signal integrity of the input-output signals. These can be either on the top of the substrate or the bottom of the substrate. And we can have a heat spreader, an IHS, which stands for integrated heat spreader. And this spreads the heat from the silicon to a larger area, so it's easier for the system to cool, using fans or immersion cooling, for example. A thermal interface material called a TIM sits between the integrated heat spreader and the silicon, and this conducts the heat from the silicon to the heat spreader. It's typically made of solder or a polymer. And then there is an adhesive that sits at the edges of the integrated heat spreader that sticks it to the substrate. Now, typically, heat spreaders are anywhere from 500 microns in thickness to 2 to 3 millimeters in thickness. And finally, I show you a cross-section. What does a real part look like? So in this part, we're showing you a silicon die, the first level interconnects using solder bumps and the C4 type of connection, and solder balls, which is typical of a ball grid array type of package, and the package substrate. And here you can see those multi-layer stack up of alternating copper and dielectric layers. Now, not all semiconductor packages have the same features. This is one example of a lidded flip chip BGA that I'm showing you here. Wire bond packages are actually one of the most common type of package. And so unlike what I showed you on the previous slide with the lidded BGA package, with flip chip lidded BGA package, the wire bond uses wires to connect the pads on the silicon to the substrate. And those pads are typically facing away from the substrate, and they can only be on the edges of the silicon because it's very difficult to get a wire into the center of the silicon. And finally, this type of package uses mold to protect the wires. It's a compression mold encapsulant over the full surface of the package. Flip chip packages, like the one we had on the previous slide, has a silicon flipped, so with the silicon pads now facing the substrate, and those are connected using solder. Of course, there's many other types of packages. List a few down here at the bottom. Pin grid arrays, quad flat packs, quad flat no leads, wafer level chip scale packages, package on package, system in package, and the list goes on. And all of these have different features, different manufacturing techniques, and different component options. In summary, the first level interconnect connects the IC chip to the package substrate. C4, a very common type of connection, is called control collapse chip connection. Other types of connections that are possible would be copper to copper type of connections, wire bond, and more. Package substrates, they consist of interconnect layers to connect the IC chip to the motherboard, typically 6 to 24 layers. Second level interconnect connects the semiconductor package to the motherboard. Ball grid array uses solder balls to surface mount to the motherboard, and a LAN grid array has pads that interfaces with a socket that has already been previously attached to the motherboard. In final summary, a semiconductor package consists of an IC chip, a package substrate that connects to the FLI, and a SLI, second level interconnect, that connects the package to the motherboard. There's many other components and features possible, like heat spreaders and capacitors. All these are dependent on the exact design and need of that package or product. Flip chip BGA is one type of package that we talked about. Wire bond, PGA, quad flat no lead packages are other types, and each of these have very different materials, design, and other considerations like reliability. Thank you for watching.